Hey guys, how's it going? Today we have a very cool trigonometry lesson. Today we can find the area of any triangle. So you heard that right. Today we're talking about area. So remind yourself, if you need to, what area is. We're talking about the space that the two-dimensional shape takes up. Okay, so all of this. If you were painting the triangle, how much paint would you need? It's this type of question. So in the past, we had one formula for the area of a triangle, and it was kind of lame, right? We wrote it as 1/2 times the base times the height. This would give us our formula. Maybe you also wrote it as just b times h over 2. Obviously, this is the same thing. The problem with this formula is, okay, let's say this is the base. Well, we need this whole other thing to figure out the area, right? Where is the height on this triangle? Well, you know well that the height is always perpendicular to the base. It's always 90 degrees to the base. So none of these sides are the height. In fact, the height can be found by going 90 degrees to the base. So if we drop a height down from here, we can find the height. So a bit cumbersome mathematically. Let's say this is 90 and this is better drawn, because we're looking for a value that isn't even part of the triangle necessarily. It might be if it's a right angle triangle and it gives you one of the sides that's part of the 90-degree angle. It could happen, but it seems pretty unlikely in real life that you run into these perfect triangles every time. So we need a new, better, more efficient way of finding the area of any triangle. And today, I'm going to show you two different ways. So the first way uses 3 side lengths. So this is called Heron's formula. And we're going to use the 3 sides of a triangle, let's call it A, B, and C, to find the area. So let's keep it in general and find our formula. Now, I want to find the formula, but before I do that, I need to define a new term, and I'm going to call it S. S is half the perimeter. What is perimeter? It's when you add up all the sides. So if I added up A plus B plus C, and then found half of that, so divided it by 2, then I would find S. And this is very, very important, because we use S in our area formula. So what is the area formula that Heron created for us? It is that the square root of this value, S, that you have to calculate every time, S, times S minus A, times S minus B, times S minus C. So maybe a big scary formula, but actually kind of easy to remember, right? Square root, and then you put S, and then it's going to be S minus each of the side lengths. So first you find S, which is half the perimeter, then you have this formula, and now we can not solve the triangle, but we could solve for the area of any triangle, given that we have the 3 side lengths. So let's see this in action. You see it's really not that complicated. So here's a triangle. They give us all 3 sides, or maybe we're halfway through the problem, if you can imagine, and we found the 3 sides, and the question wants us to find the area. Well, no problem. I know I'm going to use Heron's formula, but before I do that, you know I got to find my S value. I got to find half my perimeter. So I'm going to add them up. 12 plus 20 plus 10. These are my 3 sides, and I'm going to divide that by 2. So 12 plus 20 plus 10, that's 42. Divided by 2, that's 21. So I can find my S value to be 21. Okay, in this case, 21 centimeters is half my perimeter. Great. I am halfway home, because now that I have my S value, I can use Heron's formula. As a side note, sometimes in textbooks you might see this called Hero's formula. There's some historical reasons for this. It's the same formula. It's even talking about the same guy. but just in case you run into that, Huron's formula and Hero's formula, same. So let's plug in our numbers. I'm going to make a nice big square root sign. My value S is 21, so I'm going to throw that in. Then my value S is 21. My value of A, let's just say this is A, this is B, this is C. Sure, it doesn't really matter, right? So 21 minus the first value, 12, times, again, 21 minus my second value, which will be 20, and 21 minus my third value, which in this case is 10. So the square root is on all of this. Excuse me. So first thing you're going to do, right, just follow BEDMAS to solve this. You have 3 brackets to take care of. So perform the subtractions first. Leave the 21 alone for the first part. So 21 onto 21 minus 12 is 9. 21 minus 20 is 1. And 21 minus 10 is 11. Now you're ready to just plug this into your calculator. Perform this multiplication, 21 times 9 times 1 times 11, and find the square root of that answer. In this case, you're going to find it's 45.6. That's a 5. Excuse me. 45.6. Never forget your units. It's a unit of area. So these were in centimeters. So your unit of area would be centimeters squared, or square centimeters. 45.6 square centimeters is how we'd say it out loud. So there you go. Huron's formula, really not that complicated once you do a few examples. So I said there would be 2 ways to do this. So before we show you the second cool new way, let's remember the old school version again that we talked about at the start of this video, which was this boring old dude, 1/2 base times height. Well, this guy, as sort of lame as he is, does come in handy once again. Say we have this formula, this triangle right here, okay, and we'll name it ABC. Well, using the same convention that we used in the last video, we can name the sides. If this is angle A, then this will be side A. And if this is angle B, then this will be side B, opposite to that. And opposite to angle C would be side C. So let's just give them the names. We want to use this formula. Okay, well, let's pick a base. Let's say, since it's already oriented downwards and that's convenient, we'll say that A is the base. Okay, so that's not bad. We actually have one of the 2 variables we need. Base would be A. We don't have height, though, so we'd have to go and find height. And because we're pretty powerful trigonomic superstars, we could do that, right? Drop a height down. Let's call it H for height. And we'll use this value, the angle C, which we can go find, angle C, and set up a trig ratio to solve for H. So this is the right angle triangle we'll use. Triangle CA and then this point here. So what trig ratio would that be? Well, we have the opposite side of C, and we would have the hypotenuse of this particular right angle triangle. So opposite over hypotenuse, we're talking about sine. So sine of C is equal to, well, the opposite, in this case H, over the hypotenuse, which in this case is B, side B. Well, we want H, right? That's what we're looking for. Let's rearrange for H. H will equal B times the sine of C. Well, what we can do with this is plop it back into our old formula. So now we can rewrite this old formula in a new, more useful way. So instead of finding this whole new value H, we can just sub in what we already know about the triangle. So the base we said in this case was side A. So I'm going to write A where base was. And height is now B times sine of C. So what we're left with is this formula here, the area is equal to 1/2 of AB times C. So to put this in general terms, A and B are sides that are adjacent to the angle C. Okay? In other words, I'll say that one more time in a totally different way, or not so totally. Sides A and B sort of enclose angle C. And so we can apply this formula to any situation where we have two sides that, and we also have the angle in between those two sides. That is the information that we need. So let's remember this formula and try an example. And here, very cleanly, we can see we have an angle and we have the sides on either side of it. If we weren't given this, and say we were told this was, I don't know, 75 meters, well, then we're still out of luck. We don't have the information we need for this particular formula. Okay, we really need what is going to be the angle in between the two sides that we know. So if you're solving this triangle and you're asked to find the area, the information you can go after is this angle and two sides on either side of that angle. So let's just see how easy this formula really is now that we have it. The area is equal to 1/2 times AB sine of C. Sub in what we know. 1/2, let's just say this is the first one. So 43 times 37. Sine of our angle in between them, which in this case is 105. And you can plug that into your calculator and find that we get 768.4. And our units were in meters, so this is area, so meters squared. 768.4 square meters is how we say that out loud. And that's it. Two really great ways to find area, much more useful than our old formula, because when we're solving triangles like we've been, the information that we find is side lengths and angle measurements. So using that information, we can go ahead and find the area of any triangle. How great is that? I will see you in the next one.